All right, y'all, so we're looking at 6B tonight. And 6B deals with measures of variation. So let me move this camera up just a little bit there. So like I said, this is measures of variation. Okay, so the first thing we're going to look at is the range. So the range of a data set. So the range of a data set is the difference between its highest and lowest data values. Between its highest and lowest data values. So the official formula for the range. So the range equals high value minus the low value. So the range is basically how wide is your data. And I figured that out, like we said, by taking my highest data value and subtracting my lowest data value. So I'm just going to do an example so we can find the range real quick. So we're going to find the range of the data. And I'm just going to use test scores. So my person made a 78, 84, 92. Then they went down and made a 70, and they came back with a 88. So we just want to find the range of the data. We're not looking at the mean and any of that. So to find my range, I'm going to take my highest value. So let's say my highest value was what, the 92. And we will subtract our smallest value, which was 70. So the range or the width of this data, 92 minus 70, would leave me 22. So that basically is how wide that range of data was for this problem, okay? All right, so the range, you'll see, we're going to use the range later when we make box plots. And not specific to range as much as the high and low values, okay? So let's learn a little bit more before I actually get into the box plot. So the next thing we got to define is what we call quartiles. So what do y'all think of when you hear that word, quartiles? Oh, I'm looking for a chat. So right, so quartiles to me means things divided into fourths, right? 4 equal pieces, quartiles. So quartiles are sort of going to divide our data up into those type of sections. So we got 3 quartile dividers that we're going to look at. We got what we call the lower quartile. Often called the first quartile. So let me see, I just got one in. All righty. So the lower quartile, it divides the lowest fourth of data from the upper 3/4 of data. Okay, so it's doing like we said, it's breaking it into fourths on this. So it, like I said, it divides the lowest fourth of your data from the upper 3/4 of the data. And it's basically the median of the lower half of data. So it's the median of the lower half of data. So remember, the median is the middle of the data. So to find that first quartile, you take your lower half of your data and you find its median. Okay. So remember, if it's odd, you pick the middle number. If it's an even number of data, then you find the average of the two innermost data points. Okay. All right. So next we got the second quartile, which we often call the middle quartile. So my second quartile is found by finding the median of the entire data set. So it's the median of the entire data set. So all your points, you find their median, which is their middle, and that gives you the middle quartile, okay? So if you notice, the way we're finding all these quartiles is by the median. So they're going to ask you that on the homework, and they're going to try to trick you and make you thinking it's the mean. But remember, it is definitely the median. All right, y'all, what's next? The upper quartile. Or sometimes called the third quartile. And it's basically the opposite of the lower quartile. The upper quartile divides the lower 3/4 of data from the upper fourth. From the upper fourth of data. So the lower quartile breaks down the lower fourth, upper quartile breaks out that upper fourth. And guess what? It's the median from the upper half of the data. So it's the median of the upper half of data. All right, let me let one in real quick. All right. So y'all let y'all write that down, and then I'm going to get into box plots. All right, y'all. So next set of notes. So we use what we call.
You give me just a second to finish that first page.
All right, are you there? Hold that down right there. So we'll tell y'all the big thing on this page of notes is that there's 5 important numbers: the low value, the high value, Those are important because they give me my range. And then the lower, middle, and upper quartile are important because they break out those medians, okay? All right, you ready to go?
Give me just a few more minutes.
Oh, okay. Oh, that's right. You must have started in a little bit later on this. So you'll be good after you get this page done. So yeah, that's going to be the big thing, y'all. We're going to start these box plots, and it's going to be what we call the 5-number summary. And the box plot, the 5 numbers it's talking about are the low value, high value, and the 3 quartiles. Okay. Are y'all ready?
Yes, sir.
Okay. So the box plot. It's a visual way to represent the 5-number summary. So visual way to represent the 5-number summary. Okay, a rectangular box encloses the lower and upper quartiles so that means the 2 ends of the box. So I'm going to sort of draw the box while we're talking about it. So here's my rectangular box. So they're saying this left side here, that left side is going to represent our lower quartile. This right side, this line on the right side is going to represent the upper quartile. So that's what we mean by a rectangular box encloses the lower and upper quartiles. A line marking the median. So a line that marks the median and remember, we're talking about the median of the entire data set. So that median is going to be in between the lower and upper quartile. So it's going to be sitting in there. Might not necessarily be right in the center, but it will be between your lower quartile and your upper quartile. That line represents the median. So if you notice, the 3 medians separate this data into basically the lower quartile to the left, in between the lower quartile and the median, and then the same thing over here, in between the median and the upper quartile. And then this data out here is the other 4. So what represents that other data is what we call the whiskers of the box plot. And whiskers extending to the low and high value. To the low and high value. So that means you have a little whisker coming out the left side with a line. That's going to be the low value. Then you got a whisker coming out the right side, and that is the high value. So that's what's represented when you see a box and whisker plot. Low value, lower quartile, median, upper quartile, and the high value. Now, there's not any problems tonight that I'm going to do that deal with the box plot, but on our next class, I will definitely be doing a lot of examples going over the box plot, okay? Tonight, we're more going to focus on the next thing we talk about, which is going to be standard deviation. So here we go, standard deviation. And it's the single most used number when you describe variation. So remember, variation is how far is your data away from your mean of your data? Was it close to the average, or were these values spread out far like those outliers, okay? So we got a formula to find the standard deviation. We all want to abbreviate standard deviation like that. So standard deviation is the square root of the sum of the deviations from the mean that number is squared, and that's all over. So all this will be under this square root, okay? And then on the bottom of the formula is the total data values minus 1. And now I'm actually going to write the steps we're going to use to find standard deviation, and explains sort of how you use this formula. So y'all, I'm gonna let y'all catch up and then we'll turn over. Okay, so ready? We're going to learn the steps to calculating that standard deviation. Let me get my paper where it ain't all folded up. All right, so here we go. Steps to calculating the standard deviation. So the first thing we're going to do, we're going to compute the mean of the data set. So y'all remember how to find the mean, right? So to find the mean of my data set, I'm going to what? Add all the data points together and divide by how many data points I have. So the first thing we're going to do is find the mean of our data set. Then we're going to find the deviation from the mean for every data value. Okay. Now, I'll work this, and we definitely going to go through our steps really careful on that. All right, once we get those data values minus the mean all done, the next step we're going to do, we find the squares of all deviations. So that's what that formula was talking about, the sum of the deviations from the mean squared. This is all finding that part of it, okay? So now the number 3 step, find the sum of the squared deviations. So once we have squared all of our deviations, we're going to add that column together. We'll divide that sum by the total data values minus 1. So if you started with 10 data points, then you're going to divide by 9. Okay, subtract 1 and divide. The last step was that big radical thing. That means square root. So take the square root and get the standard deviation. I'm just going to sort of STD deviation for that, okay? So let me work an example showing y'all how to find the standard deviation. So we're going to find the standard deviation of the data. So y'all, let me find my data I was using. I have that right here. So my data points are going to be 11, 12, 12, 11, 20, 17, 10, 17, and 6. So the first thing I need, y'all, is the mean or the average of those, let's see, 1, 2, 3, 4, 5, 6, 7, 8. I got 9 numbers, so I need the mean of those 9 numbers. So I forget how to actually find that mean, so do y'all know?
You add them up and divide by your however many numbers you have.
There you go. So we're just going to add them up and divide by how many numbers we said was what, 9? So here we go. So let's add them up. 11 plus 12 plus 12, 11, 20, 17, 10, 17, and 6. So add it all together, that was 116. Let's divide that by the 9, like you said. And that's what, 12.88. So I think I'm going to call that 12.9. Just to sort of round it off a little bit. So I'm going to call that 12.9. So that is our mean. So what we need to do now is make a little chart up, or a table, I guess you'd call it. I'm going to list my X's here, which are my data points. And then I'm going to find what the X minus that mean is that we found, okay? So my first X is 11, and then I had 12, 12, 11, 20, 17, 10, 17, and 6. So that's all my data points. So to get to the next column, we take each of these X's minus the mean, which was 12.9. Okay, so let's get the first one. That'll be 11 minus 12.9, which gives me a negative 1.9. Next one is 12 minus 12.9. That's going to give me a negative 0.9. I already know I've done 12 already, so that's going to give me a negative 0.9. And I've already done 11. That gave me a negative 1.9. And I'm going to sort of explain what these negatives and positives mean. All right, so next was what? 20 minus 12.9. That's going to give us 7.1. 17 minus 12.9 is going to give me 4.1. 10 minus 12.9 gives me a negative 2.9.
How do we get 1.9?
Say again.
How did you get the negative 1.9 to start off with?
Oh, from number 11?
Yes.
Okay. So I'm taking each of these X values, these data points I had, and I'm subtracting that mean, which was 12.9. So that's what this X minus mean is. You take your X's and subtract the mean, which was 12.9. So when I did 11 minus 12.9, see how that gave me a negative 1.9?
Yes.
And that's all I'm doing down through here.
Thank you.
So like I've already figured out what 17 minus 12.9 was 4.1. So this is also going to be 4.1. So once I find my repeats, I can sort of fill them in. So the last one, what are you going to do on that one? So one of y'all know the last one, right? What's going to be here for when I put my 6 in?
6 minus 12.9.
So that gave us what, a negative 6.9 right there. So y'all let me explain what these mean. If they're negative, that means that the actual data point was that far below my mean. If they're positive, then that's how far the data points were above my mean. So like this one was negative 1.9 units from the 12.9. This one was only 0.9 units away from 12.9, but it was still smaller. These values down here that are positive, 20.
Professor Rentham, I ain't trying to cut you off, but can you repeat that about if it's negative and if it's positive so I can write that down?
So if they're negative, that means the numbers were smaller than your mean. If they're positive, that means your values were larger than your mean. And these numbers actually tell you how far was it away from that mean. Like 11, 1.9 units, but it's negative, so it's actually smaller than the 12.9. If you look at this one that had 20, it's positive because 20 is a lot larger than that mean of 12.9. So all of these are actually what we call deviations. They're deviations because they're how far each point is away from my mean, which was 12.9, okay? Right then it said, look, find the squares of all these deviations. So this next column, I'm going to have x minus the mean squared. So y'all know what it means to square something. So I'm looking at that chat. So when you square something, you're basically going to multiply it times itself. They do that because we're going to add all these up in a second, but we don't want to add negative numbers and positive numbers. So when we square all of these, it's going to make everything positive. Just think about it. A negative times a negative makes those numbers positive. And then when you square the positive numbers, 7.1 times 7.1 is going to give you a positive answer. So everything in this row has to be positive, okay? So y'all, I'm going to tell you a trick. When you square negative numbers on the calculator, put your negative numbers in parentheses. So I'm going to do parentheses, negative 1.9. Close those parentheses. And then on the left side, that X2 button, that squares it. So you're now going to square the 1.9 that's negative. So remember, a negative times a negative, better make that a positive. So I get 3.61. Y'all, watch what happens if you don't put the negative in a parenthesis. If you do negative 1.9 and square that, it's going to give you a negative number there because you didn't put it in parentheses. And the main thing you got to realize in this column is they all got to be positive. So let's do the negative 0.9. We'll square that. That's going to give me a 0.81. Negative 0.9 again is going to give me a 0.81. That negative 1.9 I've already done, that gave me a 3.61. Because what's happening, we want all these deviations, but we don't care about what direction they're in anymore. We don't care if they're negative or if they're positive. We just want all these deviations to be positive so I can add them up in a little bit. All right, y'all, what's next? 7.1. Notice I didn't need parentheses on this one because it don't have a negative. So it's going to give me, what's that, 50.41. 4.1 squared gives me a 16.81. That's a negative one, so I'm going to put it in parentheses. Negative 2.9 squared is going to give me a 8.41. 4.1 I've already done. That's going to give me 16.81. And then my negative 6.9, I'm putting that one in parentheses and squaring it. That's giving me 47.61. So y'all, here's what's up. That was the squares of all the deviations. So next thing it says is, hey, find the sum of those square deviations. So draw a little line under that. So let me pull that down just a little bit. So we're going to find the sum, and remember, sum just means add them all together. So add all these square deviations together. So you'll do 3.61 plus 0.81 plus 0.81 plus 3.61 plus 50.41 plus 16.81, 8.41, 16.81, and then 47.61. Adding all them together, I get 148.89. So y'all, that is finally the top part of that formula that I had wrote. That is now the sum of all the deviations from the mean squared. So remember, our actual formula was standard deviation equal the square root of all these x minus mean squareds added up. So it was the sum of the deviation squared divided by the data minus 1. The total data points minus 1. So check this out. We got this top part. That's what that 148.89 is. So bring over your 148.89. So what we need to figure out now is how many data points we had. So let's see, we had 1, 2, 3, 4, 5, 6, 7, 8. We had 9 data points. So this is the data points minus 1. So 9 minus 1 would leave me 8 data points. Now we'll tell you this. If you do this on your TI-83, TI-84 calculators, you can do this all in one step. Otherwise, you would divide the sum, which was 148.89, by the 8. Once you got that answer, you would then take the square root. But most of y'all use these calculators.
I got a question.
Yeah, I hear you.
Okay, so did you get that 8 from subtracting the number of the x's minus 1?
That's what I did. So I just come over here and said, okay, I got 1, 2, 3, 4, 5, 6, 7, 8, 9 of them. Subtracted 1 and got my 8. So we had 9 data values. And it don't matter what the numbers are, it just matters how many of those numbers you have, okay? All right, y'all. So to get this big radical thing, you hit the second button and the x squared button. Right above it, you see a little square root. So hit that first, then put in your 148.89 divided by 8. Now, if you notice, it all has to be up under the little radical when you work this problem, okay? So don't arrow out and then put the 8. Just do everything up under that radical. Hit enter, and we get a standard deviation. I'm going to round it to 1 decimal place. So that would be 4.3. So y'all, here's the bonus I'm going to give y'all. I'm going to show you how to do that on that calculator here. So I sent a video last night, so you might not have seen it yet. So let me show you how I would do this on my calculator. So the first thing I do is I hit the stat button because we're doing stat work, right? So hit that stat button. It's highlighted on edit at the moment. So I'm going to hit enter because it's already highlighted because we're going to edit this. So look, I need to clear out this L1 to put my numbers in. So I'm going to arrow up where it says L1, hit the clear button. And when I come back down, watch what happens. It cleared it out. So, and y'all are going to have this video to sort of go back into and see how I'm doing this. So what I'm going to do is put all 9 of these data values into my L1, okay? So I got 11, enter. So notice as I enter, it's going to put each one of my data points on my L1, okay? 12, enter. 12, enter. 11, enter. 20, enter. 17, 10, 17, and 6. Once I hit enter on all those, all my numbers are shown in L1 now. So here's the thing. We now have our data into the calculator in L1, and that just means list 1, okay? L2 would be list 2 and so on. Once you got your data in, hit second mode to quit that screen. So we've got our data put in by hitting stat and edit. To find the mean, median, standard deviation, you hit second stat. Second stat lets me do operations on those lists. Now, I don't want this row. I don't want ops. I want to arrow all the way over to the math column. If you arrowed over to math, you'll see that number 3 says mean. Number 4 says median. Number 7 here says standard deviation. So y'all, the first thing, let's find the mean, because remember a while ago we said our mean was 12.9. So let's check that. Arrow down to number 3 that says mean and hit enter. That's going to bring the mean onto your screen, okay? So now the calculator's waiting on me to tell it what to take the mean of. Well, we're going to take the mean of that list 1 that we set up, okay? So to get that list, we hit second stat again. Notice L1's already highlighted there, so hit enter. It's going to pop L1 on the screen. It now says, hey, we're going to do the mean of your L1 list. So when I hit enter, there we go. We get 12.888, which I would have rounded to 12.9 like we did a while ago. So we got the same mean as we did a while ago. So now we already got that list in there. Let's find the standard deviation. So remember, to do standard deviation, you're going to hit second stat, arrow over to math. Once you arrow over to math, go down to number 7 for standard deviation and hit enter. So now on the screen, it says standard deviation and it's waiting for me to get the list. So I need to get that list L1 again, right? So to get that list, we hit second stat. L1's already highlighted, so hit enter. So now the calculator is going to find me the standard deviation of that list. So we got, a while ago, we got like 4.3. Watch this, hit enter. In the calculator, if I round 1 decimal place, it's giving me 4.3. So if you like doing them by hand and making your chart, which ain't a bad idea to do once, just to get used to it. But y'all, that calculator, it'll add any of our numbers together, whether they're decimals, whole numbers, and it'll find that stuff really quick. Okay, so notice I hit the stat button to edit my list, put all my numbers in, then I quit that screen. To find all my means and medians, I hit second stat and then went over to the math column, okay? Once you go to math, that's going to have them all listed there. So that stuff ain't bad. It's just getting used to your calculator. So that's why I sent video last night. And then now y'all will have this video. All right, y'all.
Can I see that page for 1 second?
The page I just turned over?
Yeah.
Oh, let me get it better for you. Ooh, they just want to curl up on me. All right, so you need the top or the bottom?
That's good. Thank you.
Okay. You good?
Yeah.
All righty, y'all. So the last thing we'll look at, and then I'll show you more examples, is what we call the range rule of thumb. And this is ways to approximate the range and approximate the standard deviation when you know one or the other. So it says that the standard deviation is approximately, so that's what the curve equals means, approximately equal to the range divided by 4. It also tells me that you can find the range and approximate it if you know the standard deviation. So to find the range, you look for the high value and the low value. So the low value will equal the mean minus 2 times the standard deviation. And I'll show you that based on that problem we just did. The high value is approximately, so remember, these are approximately, is going to be the mean plus 2 times the standard deviation. So what you're saying, if you know the range, then we can almost find the standard deviation. We can get close to it if we take the overall range and divide by 4. If I don't know the range, but I know my standard deviations, I can find the low value by taking the mean minus 2 times that standard deviation. I can find the high value by taking my mean plus 2 times my standard deviations. So I'm going to focus more on that stuff on the next class when I do the main 6B homework. So tonight, I just wanted to go over a few of the support type homework problems. And then, like I said, next class, we're going to do the main course, okay? All righty, so these are going to be 6B support. So y'all, the first thing y'all are going to do, evaluate the square root. So y'all, what's the square root of 9 equal? Oh, I should be seeing my chat light up on that one.
3.
3, perfect. So let me see if someone else can get this one. How about the square root of 81?
9.
Square root of 25. So y'all getting the idea. They're just showing us this because remember we had to use that big square root in that standard deviation problem. So they're just going to bug you, give you one of those square roots to figure out and be done, okay? All right, so I'm going to let y'all copy that and then we're going to do, I got 2 more problems I want to work with you. Oh, so y'all ready? Okay. I'm going to turn this over, keep that paper.
Can you give me a few more seconds, Professor Rentham? I'm almost finished.
On the square root one? Yeah.
I got it.
And so y'all, here's the thing. This next one is to keep you good on the mean because remember, if you do it by hand, you had to find the mean of that data when you're finding all those deviations. So for this problem, they're giving me big bank waiting times. On this problem, they want me to find the mean and the median. So my bank waiting times are 4.1, 5.2, 5.6, 6.2, 6.7, 7.2, 7.7, 7.7, what's next? 8.5, 9.3, and 11.0. So what they want me to do is find the mean, median, and then we're going to sort of compare them and see what's up. So first, we're going to find the mean. So I'm not using a calculator this time. I'm just going to figure out, we're going to do this by hand. So how did y'all find the mean of this data? Oh, I heard something, but I don't know what I heard. So y'all want to find the mean, how y'all want me to do it?
Add them all together and then divide by the number of numbers.
Perfect. So what I say we had 1, 2, 3, 4, 5, 6. So we got 11 of them. So we'll divide by 11. So good job. So 4.1, 5.2, 5.6, 6.2, 6.7, 7.2, 7.7, 7.7, 8.5, 9.3, 11.0. So that gives me 79.2, and then, what did we say that was? 11, I think.
Yes.
So divide that by 11, we get 7.2 for our mean.
Wow.
So here's a question. The median, we don't have to do the calculator for the median. And you know what I was happy about? I was happy they had these numbers in order. Because if these numbers weren't in order from small to large, I would have had to put them in order to find that median. So we had 11 of them. So remember, when you got an odd number of data points, the median is exactly the middle number. So what's my median?
7.2. No.
7.2. Perfect. So that little 7.2 is sitting right in the middle. So the thing we notice about this is that the mean equals the median.
Okay.
So y'all guess what? If we was looking at the shapes of this one, remember I had symmetrical, I had left skewed, and I had right skewed. Since this mean and median are equal, that means that my graph would be symmetric. Okay? If the mean was less than the median, it would be left skewed. If the mean was greater than the median, then it would be right skewed. So it depends on where the mean is in relationship to that median, okay? All righty, let's see. I think I did this one. So this one, I did an example like number 3 already. So I'm going to do the last example, number 4, which is also find standard deviation. So we're going to find the standard deviation of 20.3, 11.2, 36.1, 34.3, 11.8, and 21.8. So I'm doing it by hand, but remember, you could knock this out on your calculator. Just put all these numbers into your L1, okay? So first of all, we're going to find the mean. So add them all together, divide by, let's see, what was that, 6 of them? So let's add them together and divide by 6. So 20.3 plus 11.2, 36.1, 34.3, 11.8, and 21.8. I added all them together, I get 135.5 divided by that 6. Gives me, I'm going to round this, I always round one more decimal place than what they used. So since they went 1 decimal place, I'm going to round this 2 decimal places until I get later in life, okay? So I'm going to make this a 22.58. All righty, so now we're to the point where we're going to make that little chart. We got our X. We'll have our X minus the mean. And then we'll find the X minus the mean squared. So let me write my X's. I got 20.3, 11.2, 36.1, 34.3, 11.8, and then 21.8. Next column, X minus our mean. So we're going to take each of our X's and subtract 22.58. So to save us time, I'm going to write what I got when I did this on the calculator. 20.3 minus 22.5 gave me a negative 2.28. 11.2 minus 22.58 gave me a negative 11.38. 36.1 minus 22.58 left me 13.52. 34.3 minus 22.58 gave me 11.72. 11.8 minus 22.58 gave me a negative 10.78. And then finally, 21.8 minus 22.58 gave me a negative 0.78. So I now have my second row with all my means, my deviations, I mean. So now we square all the deviations. Negative 2.28 times a negative 2.28 gave me 5.2. Negative 11.38 times a negative 11.38 gave me 129.5. 13.52 times 13.52 gave me 182.8. 1172 times 1172 gave me 137.4. Negative 10.78 times a negative 10.78 gave me 116.2. And then finally, the negative 0.78 times a negative 0.78 gave me a 0.6. So remember, under that column, I want the sum of that whole column. So we want to add the 5.2 plus the 129.5 plus the 182.8 plus the 137.4 plus 116.2 plus 0.6. Adding all them together gave me 571.7. So this is now the sum of all my deviations squared. So y'all remember, that's the top part of my formula, right? I got the square root. This sum goes to the top. So I got 571.7. So let me draw that better so that looks like the arrow. So 571.7. Oh, I'm having a brain freeze because I don't know what to divide that by. What are y'all dividing that by?
The data, 1, 2, 3, 4, 5, 6, 7 minus, so is it 6?
So the data was 6 here, right?
So
you wanna
5.
take that- so there you go. -1 would give you 5. So remember, just take every how many points you had, subtract 1, and that's that bottom number. So see what's happening. This square root, when you take the square roots, it's undoing all the stuff we did when we squared it. This standard deviation is basically the average of all these deviations. On average, how far were my points away from that mean, okay? So let's see what we get. We're going to do the square root. So remember, second x squared to get your square root. 571.7 divided by 5 gives me, it looks like I'm going to round it 2 decimal places. So I'm going to call that 10.69.
So what, can you redo that on the calculator again?
So I'm just doing this part right here, okay? So what I did, the first thing you got to do is get that radical. So that radical is the blue radical right above that x squared key. So hit the second button and the x squared key to get your radical. Under that radical, put your 571.7 divided by that 5 y'all gave me. Now, if you notice, that little radical, it extends all the way over all this. Everything has to be under your radical when you do this. So then I just what? Hit my enter and got my 10.69. So y'all watch this. I'm going to be nice and we're going to knock it out one more time on the calculator doing this, just to get y'all good at this. So the main thing we needed was this data. So watch this. I'm going to go edit L1 so that I can put this data in. So I'm going to hit stat. It's already on edit, so I'm going to hit enter. So remember, I need to clear this data out of L1. So I'm going to arrow up to L1 and hit that clear button. Watch this. When I arrow back down, all the data is gone that was in there previously. Let's put the new data in. 20.3, enter. 11.2, enter. 36.1, enter. 34.3, enter. 11.8, enter. 21.8, enter. So remember, I done entered all my data. So now quit that screen by hitting second mode. So I'm just going to cut to the chase. They want the standard deviation on this problem. We came up with 10.69. Let's see what the calculator tells us. So now for everything else, I'm going to hit second stat, okay? So second stat, arrowed over to the math. And we want standard deviation. So we're going to go down to number 7 and hit enter. So on my screen, it says standard deviation. Now hit second stat again, because we need list L1, which is highlighted. So hit enter. And y'all, when I hit enter again, it's about to give me my standard deviation, which is 10.69, blah, 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 which I would probably round off to 10.69 like we got. So I will say, it's tricky learning the calculator, but once you learn it on the calculator don't mind all these decimals. You know, I didn't mind that first one when we had 11, 12, and those kind of numbers. But you know, when you got decimals, and some of these problems have 2 decimal places. So let your calculator do that for you. Tricky to learn it, but once you learn it, you'll love it. Because that calculator can find the mean, median, and standard deviation really quick. So let me move that over and y'all can get the rest of that. All right, so y'all, here's the thing. So any questions from this today? Next class, what we're going to do is the main MR Course 6B homework. We're going to go through them problems. Some of them were sort of long, and I'm going to work them problems next class to get you good. So we'll be dealing with the box plots, the quartiles, and standard deviation, okay? And then remember, next class, I'm going to really talk about your stat project, which is your next project. So the thing you want to figure out is on that sheet I sent you about the stat project. You want to figure out what question you want to ask people. And then basically you got to find 20 to 25 people that you can ask. So some of the questions were, how much do you spend on a phone bill? How much time do you study a week? Anything like that, okay? Just some kind of question where you can get some data. And that's the whole trick to this project, is finding the data. And then you're basically going to find me the means and the standard deviations and all that later. So this project won't be due until right around before we go on Thanksgiving break, probably about 3 weeks from now. So we're really going to get heavy on that Thursday class, okay? All right, y'all, so here's the thing. Any questions? So not seeing any, so let me stop the recording.